MTD gents, I have a challenge for you for sauce and chips this week. So we're going to start off with Paul. Paul, I challenge you to provide me with a video of something that's very unique, very different, something very high-end, say the ultimate in technology. Paul, are you willing to accept this challenge?
Definitely.
I thought as much. Now, Colin, we all know you need significant improvement in many areas of your life. However, I would like you to find me a video about somebody who has significantly improved a part, whether it be cycle time or efficiency, within their company. Colin, are you willing to accept?
Accept.
Yes, and maybe, Colin, you can maybe learn a thing or two there and improve
Certainly.
yourself.
Probably
Now, Joe, we know you like food. We know you like engineering. Now, I would like you, Joe, to provide me with a video that brings the two of those together, food and engineering. Joe, are you willing to accept the challenge?
Yeah, no problem.
And last but by no means least, Mark, because I can't see Joe in the studio anywhere. Mark, now, I know that you're educated. We all know you're educated, but I would like you to provide me with a video on education, somewhere where we can learn a thing or two. How about that one, Mark? Are you up for that challenge?
Most certainly.
Now, you've all accepted your challenges. I have one more for you. So if you thought they were easy, now this one is extremely difficult. Well, some of you might find it more difficult than others. During your interviews, I would like you to say the words without whomever you are interviewing to notice a single thing, the words donkey magic. Are you up for this challenge?
Magic. How is that?
Yeah, definitely.
Yes, I think you'll all be able to do this. Now, viewers, if you are watching, I would like you to write in the comments box below who you thought maybe didn't get through their challenge, and maybe who you thought the interviewee kind of suspected that something was going on. So, gentlemen, now you've all accepted your challenge. I await to see what you get up to, and I will see you next week in the boardroom, where one of you will be fired.
Lyndsey, we can all learn, even at my age. Now, today I'm visiting the University of Wolverhampton. Now, these guys obviously have spent £12 million in this facility for over 600 students. Now, principally, they make a lot of parts for the motorsport industry. Now, this car here, for instance, last year's Formula 3, every part on here is manufactured in the university. Now, I'm going to take a walk over to the 2018 car. As you can see here, it's been manufactured. It's not far off being ready, and it will be racing in the 2018 series. So you can see some of the different parts. You've got composites, you've got metallics, you've got 3D printing, additive manufacturing. And when you look at some of the other products that they've got here, now this car is something very, very different again. And when you look at the actual processes of manufacturing, you've got parts here which are 3D printed. You've got parts which are machined on the Herco machines. So therefore, the whole process in this university is to actually learn, but also take that learning curve back into industry so they understand how to manufacture 3D printing or additive manufacturing using metrology inspection products as well, machining metal, and also using an EDM machine to utilize some of these parts here. Now, we've seen the end products, the end cars, the 2018 Formula 3 that's been put together. Here's some examples of the additive manufacturing 3D printed products that are going onto these cars. Now, what I'm going to show you now is a big investment by the university on the EOS machines. Now, they've got two of them here, and what I'm going to show you is a part actually being made for that Formula 3 2018 car. As you can see, it's being manufactured right here, right now, and the process then goes downstairs, and I'll talk to you about that in a moment. So if the students aren't actually using additive manufacturing for some of the end products on the car, obviously they're going to be using the metallics. Now they've invested, or the university have invested in this VMX42 Herco 5-axis machine with 18,000 RPM. So obviously you can really machine at some high levels and some high grades of material. Now the other thing that Herco have supplied them is this 3-axis machine, 15,000 RPM, gives some of the flexibility of some of the smaller components on the cars. But 2 great machines, investment from the university here through Herco. So that's the metallic side. However, we're going to be talking to Ian and Andrew. Now, Ian is from the University of Wolverhampton. Tell us a little bit about your job function, Ian.
Hello. I'm a principal technician here, principal technician for innovative product development. So, as the title described, my role is to be innovative, develop products. I do a lot of work with students, researchers, academics, but also industry. A lot of good ties with industry. Anything from single lone inventor right up to big companies who are looking to develop the processes.
And how many students do you have come through the system here?
At the moment, we've got over 700 students, so we've got a very, very good cohort, and that's across a number of degrees. Anything from mechatronics, electronics, robotics, motorsports, which is one of our most exciting courses, and also aerospace, your basic mechanical kind of courses.
Now, we know there's a skill shortage in the UK for engineers, and I presume what you've got here is a big investment to actually get a lot of young engineers that can use a lot of your processes here, leave the university and actually work on the shop floor. Is that really the idea of this university?
It is, yeah, but that's kind of twofold, really. There are a lot of universities out there investing and saying that they're teaching to meet this demand of lack of graduates, lack of engineers. It's not just about teaching them, it's about demonstrating that they can actually deliver on what they've learned. And this is how our partnerships with industry manifest themselves. So yeah, it's certainly, you've had a little look around at some of the kits. You can see that we've invested in not just current technology. We like to be on the cutting edge of emerging technologies, as we call it, and get our students to be on that cutting edge, because sooner or later that's going to be old news. So yeah, we've got to stay current. Our students have got to be current. Latest technology, latest thinking, latest approach to engineering and industry like that.
Well, you're talking about cutting edge. Now, I've got Andrew here from Warwick Machine Tools. Now, you represent Exotech in the UK. You've supplied this 650 machine. Could you tell us a little bit more about the background and journey with University of Wolverhampton?
Well, we had to meet some specific criteria that Ian gave us to cut parts which are difficult to cut that have come off the additive manufacturing machines. We had to cut parts. We had to show that we could cut them better than had been cut before on his previous machine. So we just supplied him a machine that did what he wanted it to do.
And when you look at the machines that you're supplying into the UK, are you finding that academies, universities, that is certainly an area of strength for you guys?
It definitely is. I think following on from the machine that came here, we've put a number of machines into universities and academies now to do this specific job.
That's just donkey magic, Sven.
I love these challenges. Yeah, so I'm here looking at the latest technology, as you've asked. I'm with Marcel here from OGM. Marcel, you've just recently purchased this Matsuura Lumex machine, haven't you? It's an additive subtractive. Tell us about the machine and why you purchased it.
Well, it's a very interesting machine. It's an additive manufacturing machine that's got direct metal laser sintering at the core, but it's also got a 3-axis CNC machine thrown into the corner. So it happens to be a Matsuura machine, so there you get equality thrown in. So very interesting machine, but we purchased the machine because we had a very tricky injection mouldable part, which we were finding very difficult to get tight tolerances on. And for a project, we gave it to Matsuura and said, can you beat that? Can you do anything with it? And they put some 3D waterways into it, used it on one of their machines in Germany and built us a part, and we got a 20% reduction in cycle time.
Impressive. Now, the good thing about additive and subtractive is obviously you build the part up and then you machine it. Now, I believe this builds it up in layers, doesn't it? Is it 5 layers and then you do one machining, one subtractive operation?
That's right. It actually builds up in 10 layers, and it's 50 microns for each layer. So after 10 layers, you get to 0.5 millimetre, and then the 3-axis CNC machine comes along and does the machining if you require it to. So it's a high-speed machine, so the accuracy is absolutely outstanding and a very good surface finish.
Where's the benefits of having the subtractive as well? I suppose if you look at mould tools, or you look at parts that you're having to do channels in, for example, they can be quite rough if you're just layering them up. But with this, you can actually machine those channels as well, can't you? That's one area.
Yeah, that's one of the big areas really. Conformal cooling paths in injection mould tools, really important to take the heat out of the mould tool during the moulding process, because you get an awful lot of heat build up. So traditionally, if you put them in, you normally used conventional drilled holes, and they tend to be just sort of at right angles and then plugged at the end, so you don't get the conformal cooling that you would expect. So with this technology in the 3D CAD, you get the conformal cooling, so you can take the waterway right up to the surface of the metal part, extract all the heat, and with the benefit of this 3D printer, the CNC machine, you can have the waterways machined nice and smooth, so you don't get any blockages within the waterways, making the waterways smaller.
And you're also reducing operations as well. You're not just layering a part up and then having to take it off and put it onto another machine to machine it. Reducing operations. But also with that reducing of operations and the machining, you can get more accurate location points and things on parts that you're building, can't you?
That's right, yeah. There was a project done recently by Matsuura for a part for an aeroplane engine. And it was a very large part, and actually what they did is they used the technology to actually print the part. They didn't machine it because the machining would have taken far too long with the small machining head on it. So what they did is they machined the actual fixing locations and used those then to post-machine the very large surface area, which they did on a traditional 5-axis milling machine. So it's understanding its benefits and using that location technology for that purpose.
And before you bought this, you would have looked at it and you've thought, I hope in 6 months' time I'm going to be able to do this and do that and all the rest of it. Are you ahead of what you would have hoped to have got out of this type of technology?
Good question. It's early days at the moment. There's an awful lot we've learned in the last 3 or 4 months with this technology, and we've got an R&D program running in the background at the moment, and there's an awful lot of interest in that, and we've got some very interesting patentable ideas and innovations that we might play with. So watch this space.
And just a few words on Matsuura's support and service through this journey. I know Joe is employed specifically to look at additive manufacturing. Is he being a good guy for you?
Yep, he's absolutely outstanding. He's been really helpful. He's on the end of the phone all the time. He reads the CAD if I send it to him and ask him for help. And he's got lots of good hints and tips. He's very experienced in this technology, so it's very, very useful.
So a bit like winning the lottery, is it, having this machine?
Absolutely, it's a bonus.
Let's hope I can join you tomorrow, because I've got 10 to 1 on Donkey Magic.
Okay, so I've travelled to Tewkesbury today to Quick Bend Systems, and I'm here to see Finley. I've been sent looking for food, so hopefully they're going to be vending food. Finley, good to see you again.
Hi Joe.
You well?
Nice to see you.
This is the new vending machine.
That's right, this is the Quick Vend Compact that we'll be launching at Mac.
Brilliant. And what does it do? Obviously it vends tools, but why do we have a small one?
Well, it's for localised tooling for particular cells or departments. So rather than having one large system or central stores, you get true point of use by locating this within departments or cells.
Okay, so if you're small manufacturer and you don't need one of these large vending machines, it works. Equally, if you're a big company with lots of different cells, use it for localised. I've got to tell you, I've been sent here looking for food, so I'm slightly disappointed that you haven't got any food to vend.
Oh, cripes. Well, you've had some trouble with your emails, haven't you, Joe?
Always.
Let's see what we've got in here, then. Ah, we have some spam.
Oh, there we are. So, spam. If I was a donkey, I'd say that was magic. Well done.
Cheers, Joe.
See you again.
Guys, thanks for setting me a challenge. Now, you donkeys, I could rely on you. You give me an address and everything like that. I thought, magic, I'm off to Wales. But, as is usual, horsing around, I've actually ended up in Havant, in Hampshire. So instead of Swarford chips, fish and chips?
If you want, we've got plenty down here on the south coast.
Okay. Now, I'm not going to go into what and Air do, but, well, very briefly, fuel systems for aircraft.
Yeah, that's it. We make lots of interesting parts in aluminium.
Yeah. And we've just done a video for your new Citizen Miano, let me get this right, ABX64 SYY2.
That's it, yep.
So twin spindle, twin turret?
Correct.
Yeah. You absolutely love the machine. They've bought 5 Citizen Mianos over the last 14 years?
Yeah, that's right.
Okay. So massive fans, but again, we've done a video about that, so that's coming soon. What I want to showcase is these parts here, which have really, this machine's really turned the production around. So first this part.
So yeah, I mean, this particular part has to be highly accurate.
Yeah.
This internal groove is sealing something else inside there, but also this thin wall, we're keeping this thin diameter all the way down.
It's only about 1 mil.
1 mil, yeah. And making it in one part.
Yeah.
Both sides are being done simultaneously.
Okay.
So it's very good low cycle time.
So great sort of testimony to the Citizen machine in terms of accuracy, complexity. So next part.
Next part, well, it originally was designed for our older Miano machines.
Yeah.
It was made in 3 parts because of the limitations on the sub spindle and main spindle.
So no limitation machine, just the diameter of the bar.
Exactly, yeah. Now, because of the ABX, we can manufacture it in one part, and we've got so much tooling available as well. We've added extra parts, added features to it, like this milling here, and the Y-axis milling can be done all in
And then
the same
boring
part.
down the centre,
Yeah.
circle interpolated.
Yeah, well, this central bore is slightly off centre.
Like I say, let me just check. I was looking at Owen thinking, hold on a minute, what's gone? That's just off centre.
It's just off centre, yeah.
It's supposed to be.
It's supposed to be, yeah. And so that's circular interpolated and milled out. We found that's the best way of making that particular part.
So previously, no restrictions on the accuracy or complexity of what the machine can do, just the bar diameter. This is a bigger bar, 64 mil.
Yeah, well, our old machines didn't have a Y-axis.
Right.
This particular...
And it's got a Y-axis on
both heads, yeah. So it means that we can do something like this, which is obviously 64 mil diameter. We just skim it, you know. We mill it, but not only are we milling it, we're milling it simultaneously as well. Both heads are running together, milling this out.
So balance turning.
Balance turning. We do balance turning as well, either on the sub spindle or the main spindle.
Sorry, but you said milling there. I do apologise. So what are you actually doing on this part?
So we're milling this square, this flat here. We're circular interpolating this radius here because it's a different radius to the main spindle. So it's using the Y and the X and the C axis all simultaneously. Yeah, the controller's got quite a lot to think about when it's doing that bit.
But in terms of the machine, complexity and simplicity of the user control and things like that, no issues at all.
Yeah, that's it, yeah. Okay,
and now we've got a limited amount of time, but what's this next part?
Well, this is probably one of the most complicated parts that we manufacture. It's it's obviously just a right angle fitting, but it's the beauty of the machine because we can manufacture this in one part, one go. You see.
So previously it was 3 ops.
We had to cut the billet on the saw, put it in the mill. There was 2 ops on the mill, and then we had to machine the thread on it on the lathe.
So yeah, quite time consuming. Whereas on the ABX 64 SYY2, get that right?
That's it. That's exactly it. It can be manufactured in one go. Right. So we're using both heads simultaneously. So you know, one particular part in the program, it's milling this square and milling out some of this roughing milling here, and then drilling holes and radiusing around here. So it's a very adaptable machine. You can do lots of things with it.
Owen, thanks for showcasing the components you manufacture on the Miano machine. It's absolutely amazing. You're obviously very, very happy with it.
Yeah, I love it. Yeah.
What I'm not happy with, though, is you muppets, not donkeys, as I said earlier. So thanks for sending me to Havant, which we had a great day here. Back to you guys.